Welcome to the deep dive. Today, we're going to be diving into the world of distributed
Oh,
systems.
exciting.
Yeah, specifically to, pretty important ones that you might not have heard of, ZooKeeper and Chubby.
Okay.
And you wanted to get a handle on these systems, and
Yes.
you've come to the right place.
Right.
So these aren't just, random bits of software. We're talking about the behind-the-scenes players keeping giants like Google and Yahoo running smoothly.
Hmm.
And what's fascinating to me is how they're almost like digital orchestra conductors, making sure a huge network of servers doesn't, just fall into chaos.
Yeah, precisely.
Yeah.
Imagine trying to run services like search or email with thousands of computers all needing to share information, coordinate tasks
Right.
without stepping on each other's toes.
Yeah.
That's the challenge.
Yeah.
ZooKeeper and Chubby solve.
Okay, so coordination is the key word here.
Yeah.
But what does that actually look like in practice? Is it like sending out memos and holding like server meetings?
Well, not quite. One of the critical things they handle is something called leader election.
Okay.
So imagine a cluster of servers needs to decide who's the boss, the one responsible for certain tasks.
Right.
ZooKeeper and Chubby help them hold a sort of digital election, making sure there's always a leader, even if one server crashes.
Oh, okay.
Yeah.
So no more server popularity contests or
Okay.
backroom deals.
Right.
So it's all automated and make sure that things are, stable.
Yeah,
From what I've gathered, ZooKeeper and Chubby take different approaches.
they do.
I'm really curious about those, those differences.
Yeah.
Can you walk us through those?
Absolutely. ZooKeeper, developed at Yahoo, is the speed demon of the two.
Okay.
It can handle an incredible amount of traffic, hundreds of thousands of operations per second.
Wow.
This makes it perfect for situations where you're constantly checking the status of servers or fetching bits of configuration data.
Got it.
It's designed to be incredibly fast, especially for those quick read operations.
So if your application is constantly checking in and asking, hey, are you up? What's the latest setting?
Yes,
ZooKeeper's the guy.
exactly. And what makes ZooKeeper even more interesting is that it uses a hierarchical structure,
Okay.
similar to a file system,
Okay.
with these data nodes called nodes.
Got it.
It's like a mini specialized file system just for your servers.
Wait, so it's not just about coordination.
Right.
It's about providing a way for all those servers to have like a shared understanding of how things are organized?
Exactly.
That's a clever way to simplify things.
Yes. And developers can even set up watches
Okay.
to get notified whenever specific data changes.
Oh, okay.
This means they don't have to constantly poll the system asking, anything new, anything new. It's like having a live feed of the most critical information.
Okay, so that's a pretty elegant way to keep everything in sync.
Yeah.
So where does Chubby fit into this picture?
So Chubby, developed at Google, takes a slightly different approach.
Okay.
It prioritizes reliability and availability above all else.
Okay.
Think of it as the rock-solid foundation of your system, designed to avoid data loss even if a server crashes.
Okay, so if ZooKeeper is the speedy messenger,
Right.
Chubby's the vault where you keep the crown jewels,
Precisely.
data integrity is paramount.
It is paramount.
Okay.
Chubby uses a consensus protocol called Paxos
Right.
to ensure multiple servers agree on any changes before they're made permanent.
Got it.
This means that even if one server goes down, the data is safe and sound.
Right.
It's designed for those critical situations where consistency is key.
Got it. So Chubby's all about making sure every decision is carefully validated
Yes.
and agreed upon by multiple parties before any action is taken.
Yeah,
It's like having a board of directors for your data,
exactly.
ensuring everything is done by the book.
Exactly.
And one of Chubby's, standout features is its locking mechanism.
It is.
Think of it as like a digital lock on a shared resource, like a file or a database.
Yes.
Only one server can hold the lock at a time, preventing conflicts and making sure everyone's playing by the rules.
Exactly.
This locking mechanism seems crucial.
Yeah.
It's like a traffic cop directing server traffic,
Wow.
making sure everything flows smoothly and there are no collisions.
Yes.
So when would you choose one over the other? They both sound pretty important.
That's a great question. One key difference is how they handle read operations.
Okay.
Remember how we said ZooKeeper was all about speed?
Mhm.
Well, it uses a clever wait-free approach where servers can answer those quick read requests directly from their own local copy of the data.
Okay.
This makes things super fast.
Got it.
Chubby, however, takes a more cautious approach.
Oh,
It directs all requests, including reads,
okay.
to the master server.
Got it.
This might be slightly slower for reading data,
Right.
but it offers a stronger guarantee that everyone is seeing the most up-to-date information.
So with ZooKeeper, you get speed,
Yeah.
but with Chubby, you get the absolute latest information
You got it.
every time.
Every time.
It's a classic trade-off between speed and consistency.
It is.
And it sounds like choosing the right tool just depends on, your specific needs.
Absolutely.
What other differences should we keep in mind?
Another important distinction is their locking mechanisms.
Okay.
Chubby, with its focus on reliability,
Yeah.
uses a coarse-grained locking approach.
Okay.
This means the lock covers a larger chunk of data,
Okay.
making it suitable for tasks that take a bit longer to complete.
Right.
ZooKeeper, however, offers more fine-grained control,
Oh,
letting you lock down individual pieces of data.
got it.
This is perfect for situations where you need to be very precise and don't want to block other processes unnecessarily.
So Chubby is like putting a big fence around an entire construction site,
Yes,
while ZooKeeper lets you carefully rope off individual areas,
that's right.
allowing work to continue in other parts.
Yeah.
That makes sense. Are there any other key differences we should be aware of?
Yes, one more thing to consider is failover, which is how these systems handle a server going down unexpectedly.
Right.
Chubby has this clever feature called a grace period.
Okay.
If the master server goes down, clients can keep working with their cache data for a short period,
Okay.
even though they can't make any changes.
Right.
This gives the system time to elect a new master without disrupting ongoing operations.
That's a pretty clever way to handle those unexpected hiccups.
Yes.
It's like having a backup generator kick in when the power goes out, keeping things running until the main system is back online.
Exactly.
And this highlights how Chubby's design prioritizes data safety and consistency of all else.
Yeah.
It's built to withstand those unexpected events and ensure the integrity of your data.
That's right.
Okay, so we've got ZooKeeper, the speedster. That's great for constantly checking in and fetching data.
Yeah.
And we've got Chubby, the rock-solid vault, ensuring data integrity and preventing conflicts.
Yes.
Both sound incredibly complex, but also surprisingly elegant in how they solve these distributed system challenges.
Yeah.
What really blows my mind is that they weren't just used for what they were initially designed for.
That's right.
Both ZooKeeper and Chubby ended up being heavily used for naming services,
Right.
even though that wasn't their primary focus.
Yeah, it's really interesting, isn't it? It speaks to the
It does.
ingenuity of developers.
Yeah.
They saw these tools, understood the underlying mechanisms,
Right.
and thought, hey, we can use this for something completely different.
It's like giving someone a hammer and they end up building a whole house with it.
Precisely.
Who would have thought?
Yeah, it shows that sometimes the most unexpected uses for a technology turn out to be the most valuable.
Absolutely. Now, speaking of unexpected uses, I'm sure these systems have had their fair share of challenges, haven't they?
Of course.
No system is perfect, right?
No, it's not.
So what were some of those,
Well, one challenge Chubby faced was dealing with what we call abusive clients.
okay.
These are clients that make an excessive number of requests, potentially overwhelming the system.
The digital equivalent of someone hitting the refresh button 1,000 times,
Exactly.
slowing things down for everyone else.
That's right.
So how do you deal with that?
Well, they had to come up with strategies to mitigate these issues.
Right.
Which is always a good reminder that designing for the real world means considering both the ideal and, well, less than ideal scenarios.
Right. And remember how we talked about Chubby's incredible reliability?
Yes.
Well, that also led to some unexpected challenges, right?
That's right. In the early days, Chubby didn't have storage quotas.
Mm.
Developers, being resourceful as they are, started using it to store large amounts of data,
Right.
which it wasn't designed for.
It's like using a shoebox to store your entire wardrobe.
Exactly.
Not exactly the best fit.
Not the best fit. This highlighted the importance of setting clear design constraints and educating developers about the intended use of a system. You have to think about how people might use or misuse the tools you create.
It's a constant evolution, isn't it? You build something, you learn from how it's used, and then you adapt.
Absolutely. And don't forget the difficulties in implementing reliable failover mechanisms,
Right.
especially when proxy servers are involved.
Yeah.
It's a constant back and forth between ensuring stability and keeping those servers humming.
So it's not just about building a system. It's about making sure it can gracefully handle those real-world hiccups and keep running smoothly no matter what.
Precisely. Building robust distributed systems is an ongoing challenge, but systems like ZooKeeper and Chubby have provided invaluable lessons for the next generation of distributed technologies.
Well said. They've truly paved the way for even more sophisticated systems to emerge. But before we get too ahead of ourselves, let's take a quick break. When we get back, we'll delve deeper into the inner workings of these fascinating systems and explore some of their real-world applications. Stay tuned.
Welcome back. Before the break, we were discussing the unique approaches of ZooKeeper and Chubby, and it struck me that their elegance lies in how they take relatively simple concepts
Yeah.
and use them to solve really complex problems.
You're right. And I think for our listeners, it's worth getting a little deeper into how these systems actually work under the hood.
Yeah.
It's one thing to know they're like conductors or vaults, but understanding the nuts and bolts can be really eye-opening.
Absolutely. Let's revisit those nodes we talked about in ZooKeeper.
Okay.
Remember, they're like the files and folders in that mini file system.
Right.
Well, they're not just for storing data. They're the foundation for some really cool features.
Okay, give me an example.
Sure.
What else can you do with these nodes besides just stuffing information into them?
One clever use is for something called ephemeral nodes.
Okay.
These are special nodes that only exist as long as the server that created them is active.
Oh, okay.
Think of them like temporary sticky notes that automatically disappear if a server goes offline.
So it's a way to automatically track which servers are up and running without constantly pulling them.
Exactly.
If the sticky note vanishes, you know something's wrong.
Exactly. It's a simple but powerful way to monitor the health of your service.
Right.
And this is just one example.
Okay.
ZooKeeper uses these nodes for all sorts of coordination tasks,
Yeah.
like managing group memberships, and even those leader elections we talked about earlier.
It's amazing how much you can do with these simple building blocks.
It is.
Now, I remember we briefly touched upon Chubby's use of the Paxos protocol for reliability.
Right.
I have to admit that one went a bit over my head.
Sure.
Can we unpack that a little more?
Of course.
What makes Paxos so special?
Paxos is a way to ensure that multiple servers in a Chubby cell agree on any changes before they're made permanent.
Okay.
Remember how we emphasized Chubby's focus on avoiding data loss?
Yes.
Well, Paxos is the secret sauce that makes that happen.
Okay.
It's all about making sure everyone is on the same page, even if some servers are temporarily unavailable.
Okay, so it's like having multiple copies of a really important document and ensuring everyone is working off the same correct version.
Exactly.
But how does that actually work in practice? It sounds like it could get messy with everyone trying to chime in and update things.
It does involve a lot of back and forth communication between the servers.
Yeah.
Sort of like a carefully choreographed dance.
Okay.
They propose changes, vote on them,
Right.
and keep exchanging messages until they reach a consensus.
Got it.
It can seem complicated,
Yeah.
but the elegance of Paxos is that it works even if some servers crash or communication is disrupted.
So even if there's chaos in the network, Paxos keeps the data consistent.
Keeps it consistent.
That's pretty impressive.
Yeah.
But all this technical talk has me wondering about the real-world applications of all this.
Uh-huh.
We've mentioned leader election and server status tracking, but
Yeah.
where else do we see these systems in action?
Oh, the applications are vast. Let's start with ZooKeeper. Remember how we talked about its strength in handling a ton of read operations?
Yes.
Well, that makes it ideal for configuration management.
Okay.
Imagine you have a huge distributed application with hundreds of servers,
Right.
and you need to update some settings across all of them.
That sounds like a nightmare to do manually.
It would be a night.
Logging into each server, making the change,
Yeah,
it'd be incredibly time-consuming.
incredibly.
Yeah.
But with ZooKeeper, it becomes incredibly simple.
Okay.
You can store the configuration data in a node,
Right.
and all the servers can be set up to watch that node.
Right.
As soon as you update the configuration, boom, all the servers get notified and update their settings automatically.
Wow. So it's like having a single source of truth that everyone can reference.
Exactly.
No more manual updates or inconsistencies.
That's right.
That's incredibly powerful.
It is. And that's just one example.
Okay.
ZooKeeper is also widely used for service discovery. This is where servers can register themselves and their capabilities, allowing other servers to find and connect to them dynamically.
So it's like a directory service for servers,
It is.
helping them find each other in this vast, complex network.
Exactly.
Sort of like a phone book for the internet.
You got it. And ZooKeeper's speed and scalability make it perfect for managing the constant changes that happen in large distributed systems where servers are coming online and going offline all the time.
Okay. That makes a lot of sense for ZooKeeper.
Yeah.
Now, how about Chubby? What kind of real-world problems does its focus on reliability help solve?
Well, one of the most important applications is in distributed locking.
Okay.
Imagine you have multiple servers that need to access a shared resource like a database.
Right.
You don't want them all trying to modify the data at the same time.
Right.
That can lead to all sorts of problems.
It'd be like having multiple people trying to edit the same document simultaneously.
Yes.
Things could get corrupted pretty quickly.
Very quickly.
Yeah.
Chubby's locking mechanism makes sure that only one server at a time can access that shared resource,
Okay.
preventing conflicts and ensuring everything stays consistent.
So it's like having a bouncer at the door, making sure only one VIP gets access at a time.
That's a great analogy.
It's all about maintaining order and preventing chaos.
That's right. And this locking mechanism is just one example.
Okay.
Chubby is also used for things like master election in distributed databases,
Right.
ensuring there's always a leader,
Right.
and for storing small amounts of critical metadata that needs to be highly available and reliable.
It sounds like Chubby plays a crucial role in keeping these complex systems running smoothly.
It does.
It's the unsung hero working behind the scenes to ensure everything stays stable and consistent.
Exactly. And what's truly remarkable is that these systems, while complex under the hood,
Yeah.
were built on relatively simple ideas.
Right.
It's a testament to the ingenuity of the engineers who designed and built them.
You know, it's easy to get lost in the technical details, but it's worth stepping back and appreciating that elegance.
Absolutely.
They took these fundamental concepts and used them to create solutions that have shaped the entire landscape of distributed computing.
That's right.
But I'm curious, are these systems still relevant today, given how much technology has advanced?
That's a great question. And the answer is a resounding yes.
Okay.
While the specific implementations might have evolved,
Right.
the core concepts behind ZooKeeper and Chubby are more relevant than ever.
Okay.
We live in a world of cloud computing, microservices, the Internet of Things.
Yeah.
All these trends rely on distributed systems.
Right.
And the challenges of coordination, consistency, and reliability are even more crucial in these environments.
So it's like they laid the groundwork and everything that's come after has built upon that foundation.
Exactly. In many ways, ZooKeeper and Chubby were ahead of their time.
Yeah.
They anticipated the need for these types of coordination mechanisms.
Right.
And their ideas continue to influence modern distributed systems.
Yeah.
They're part of the DNA of how we build large-scale, reliable applications today.
It's fascinating how these pioneers have shaped the technology we use every day.
It is.
But I'm also curious about the challenges they faced.
Yeah.
Every great invention has its share of hiccups, right?
Of course.
What were some of the unexpected hurdles they had to overcome?
Absolutely. One common challenge faced by both ZooKeeper and Chubby was dealing with what we affectionately call abusive clients.
Oh, you mentioned them before the break.
It did.
Those are the ones bombarding the system with requests.
Yes.
Like someone frantically hitting refresh, right?
Exactly.
Yeah.
These clients, whether intentionally or not,
Right.
can put a huge strain on the system.
Right.
So the engineers had to implement mechanisms to rate limit these clients,
Right.
prioritize critical requests,
Right.
and sometimes even intervene manually to resolve the issue.
It sounds like a constant battle trying to keep those pesky clients in check.
It can be. And another challenge, specifically for Chubby,
Yep.
stemmed from its lack of storage quotas in the early days.
Oh, right.
Developers, always resourceful,
Yeah.
started using Chubby to store large amounts of data, which it
Wow.
wasn't really designed for.
Right. We talked about the shoebox analogy earlier.
Yeah,
It's
yeah.
too much stuff crammed into a small space.
Exactly. This highlighted the need for careful planning and considering potential unintended consequences. They had to implement quotas and educate developers about the limitations of the system.
Right.
You have to think about how people might use or misuse
Yeah.
the tools you create.
It's a good reminder that even the most brilliant engineers can't predict everything.
That's true.
But that's part of the fun, right?
It is.
Solving those unexpected problems and making the system even more robust.
Absolutely. And these challenges provided valuable lessons for future distributed systems.
Okay.
We've learned the importance of setting clear boundaries, implementing safeguards,
Right?
and constantly monitoring for potential issues.
Right. It's like raising a child. You have to set clear expectations and be prepared for the occasional tantrum.
That's a great analogy. Building a distributed system is much the same.
Yep.
Constant learning,
Right.
adapting, and refining.
Well said. Now, another topic we touched on earlier was failover mechanisms.
Right.
It seems like a critical part of these systems,
Yeah.
ensuring they can gracefully handle server failures.
It is.
Can you tell us more about how they approach this challenge?
Absolutely. Both ZooKeeper and Chubby have sophisticated mechanisms for handling failover.
Okay.
ZooKeeper, remember, is all about speed.
Right.
So it relies on a very fast leader election process.
Got it.
When the current leader server goes down,
Yeah.
the remaining servers quickly elect a new leader, minimizing any downtime.
So it's like a seamless transition of power, ensuring the orchestra keeps playing without missing a beat.
Precisely. And this speed is critical for applications that require high availability
Right.
and can't tolerate even brief interruptions.
That makes sense. Now, how does Chubby handle failover with its emphasis on reliability?
Chubby's approach is a bit more cautious.
Okay.
It uses this concept called a grace period
Right.
to ensure no data is lost during failover.
Right.
When the master server goes down,
Yeah.
clients enter a grace period where they can continue working with cached data,
Okay.
but can't make any changes.
Right.
This gives the system time to elect a new master without risking any data corruption.
So it's like a temporary pause,
Yes.
giving the system time to recover and elect a new master without risking any data corruption.
Exactly.
Okay.
Once the new master is elected,
Yeah.
clients can resynchronize their data and resume normal operations.
Right.
This guarantees data integrity, even when unexpected failures occur.
So it's like having a safety net for your data,
Yes.
making sure that even if the system stumbles,
Uh-huh.
it can recover gracefully.
Exactly. And these failover mechanisms highlight the different design philosophies of ZooKeeper and Chubby, one favoring speed and the other reliability.
Right.
Each approach has its own strengths and weaknesses.
Yeah.
And the best choice depends on the specific needs of the application.
It's a classic trade-off.
It is.
But it's also a testament to the ingenuity of engineers.
Yeah.
Finding creative solutions to these complex challenges.
It is.
You know, it's fascinating to see how these systems,
Right.
while seemingly complex,
Yeah.
are built on relatively simple concepts.
Right.
It's all about using those concepts in clever ways to create solutions for the unique challenges of distributed systems.
That's the beauty of computer science.
Right.
Taking simple ideas and combining them to create something truly powerful.
Absolutely. Now, I can't help but wonder, these systems were created years ago,
Right.
and technology has advanced so much since then.
Yeah.
Are they still relevant in today's world?
That's a great question, and the answer is a resounding yes.
Okay.
While the specific implementations might have evolved,
Right.
the fundamental concepts behind ZooKeeper and Chubby are still very much relevant.
Okay.
The challenges of coordination, consistency, and reliability are even more critical today with the rise of cloud computing, microservices, and the Internet of Things.
So it's like the foundation they laid is still strong,
Very strong.
even as the building on top of it changes and grows.
Exactly. In fact, many modern distributed systems are inspired by the ideas and principles pioneered by ZooKeeper and Chubby.
Right.
They become part of the DNA of distributed computing.
It's fascinating to see how these early pioneers have shaped the landscape of technology.
It is.
But I'm also curious about the challenges they faced, the unexpected hurdles they had to overcome.
Yeah.
Every great invention has its share of hiccups, right?
Of course they do.
What were some of those?
Well, one of the more common issues faced by both ZooKeeper and Chubby was dealing with what we affectionately call abusive clients.
Oh, I've heard that term before.
You have.
What exactly does it mean in this context?
Well, imagine you have a client that's constantly bombarding the system with requests,
Okay.
perhaps due to a bug in their code,
Right.
or simply because they're not aware of the impact their actions are having on the system.
Okay.
This can overload the servers and cause performance issues for everyone.
So it's like someone constantly hitting the refresh button,
Yes.
causing the website to slow down for everyone else.
That's a perfect analogy.
Okay.
And this can be a real headache for the maintainers of these systems.
Right.
They have to implement mechanisms to rate limit these abusive clients, prioritize critical requests,
Right.
and sometimes even intervene manually to resolve the issue.
It sounds like a constant game of whack-a-mole trying to keep those pesky clients in check.
It can be.
Mm-hmm.
And another challenge both systems faced was the lack of storage quotas in their early designs.
That sounds familiar.
Yeah,
Remember that anecdote about Chubby being used to store massive amounts of data?
exactly.
Yeah.
Without quotas, developers could unknowingly fill up the available storage, causing performance issues and even system crashes.
It's like forgetting to take out the trash and letting it pile up until it takes over the entire house.
That's a vivid image.
Yeah.
And this issue highlighted the importance of careful planning and considering the potential for unintended consequences.
Right.
They had to implement quotas and educate developers about the limitations of these systems.
It's a reminder that even the most brilliant engineers can't predict every possible scenario.
That's right.
But that's also part of the fun, isn't it?
It is.
Solving those unexpected problems and making the system even more robust.
Absolutely. And these challenges also led to valuable lessons for the next generation of distributed systems.
Right.
We've learned the importance of setting clear boundaries,
Okay.
implementing safeguards, and
Right.
constantly monitoring for potential issues.
It's like raising a child. You have to set clear expectations and be prepared for the occasional tantrum.
That's a great analogy.
Yeah.
And just like raising a child, building a distributed system is an ongoing process of learning, adapting, and refining.
Well said. Now, I'm curious about the failover mechanisms you mentioned earlier.
Yes.
It seems like a crucial aspect of these systems,
It is.
ensuring that they can gracefully handle server failures.
Absolutely.
Can you tell us more about how they approach this challenge?
It is. And both ZooKeeper and Chubby have implemented sophisticated mechanisms to handle failover.
Okay.
ZooKeeper, with its focus on speed,
Right.
relies on a fast leader election process.
Okay.
When the leader server goes down,
Right.
the remaining servers quickly elect a new leader,
Okay.
minimizing downtime.
So it's like a seamless transition of power.
Yes.
Ensuring that the orchestra keeps playing without missing a beat.
Precisely. And this speed is crucial for applications that require high availability and can't tolerate even brief interruptions.
Makes sense. Now, how does Chubby handle failover with its emphasis on reliability?
Chubby's approach is a bit more cautious. It uses a concept called a grace period to ensure that no data is lost during failover.
Okay.
When the master server goes down,
Right.
clients enter a grace period where they can continue working with the cache data, but they can't make any changes.
So it's like a temporary pause,
Yes.
giving the system time to recover and elect a new master without risking any data corruption.
You got it. And once the new master is elected,
Uh-huh.
clients can resynchronize their data and resume normal operations.
Right.
This ensures data integrity, even in the face of unexpected failures.
It's like having a safety net for your data,
Yeah.
making sure that even if the system stumbles,
Uh-huh.
it can recover gracefully.
Exactly. And these failover mechanisms highlight the different design philosophies of ZooKeeper and Chubby speed versus reliability.
Right.
Each approach has its strengths and weaknesses, and the best choice depends on the specific requirements of the application.
And a classic trade-off.
It is.
But it's also a testament to the ingenuity of engineers finding creative solutions to these complex challenges.
Indeed. And the lessons learned from these systems have been invaluable for the development of modern distributed technologies.
It's like they've set a high bar for future systems,
Yeah.
inspiring innovation and pushing the boundaries of what's possible.
Well said.
Now, speaking of pushing boundaries, I remember reading about some unexpected ways that both ZooKeeper and Chubby were used.
Uh-huh.
It seems like developers often find creative ways to repurpose technology for tasks it wasn't originally intended for.
That's the beauty of innovation, taking something designed for one purpose and finding new and exciting ways to use it.
Right.
And both ZooKeeper and Chubby have been prime examples of this phenomenon.
I'm eager to hear some examples.
Okay.
What kind of unexpected uses did they find their way into?
One of the most surprising uses, and perhaps the most widespread,
Okay.
was for naming services.
Wait, naming services? That doesn't sound very exciting.
I know.
What's so special about that?
It might not sound glamorous, but naming services are a crucial part of any distributed system.
Okay.
They provide a way for servers to find and connect to each other using human-readable names instead of cryptic IP addresses.
Right.
Think of it like the phone book of the internet.
Ah, so it's like having a directory that lists all the servers and their services,
Yeah.
making it easy for other servers to find what they need.
Exactly.
Okay.
And both ZooKeeper and Chubby,
Mm-hmm.
with their hierarchical namespaces and ability to handle updates efficiently,
Yeah.
turned out to be perfect for this task.
So it's like they accidentally stumbled into a new career path
Yeah.
and they excel at it.
That's a great way to put it. And this unexpected use highlighted the versatility of these systems.
Right.
They weren't just limited to their original design goals. They could be adapted and extended to solve a wide range of problems.
It's a reminder that sometimes the most innovative solutions come from unexpected places.
They do.
What other surprising applications did they find?
Another interesting use was as a rendezvous point for distributed applications.
Rendezvous point. What does that even mean in this context?
Imagine you have a distributed application with multiple components that need to coordinate their actions.
Okay.
They might need to share data, exchange messages,
Okay.
or simply signal to each other that they're ready to proceed.
So it's like setting up a meeting point where all the different parts of the application can sync up and make sure they're on the same page.
Exactly. And both ZooKeeper and Chubby,
Okay.
with their ability to store data,
Uh-huh.
handle watches,
Yeah.
and provide reliable locking mechanisms,
Right.
turned out to be perfect for this role.
It's like having a virtual conference room where all the different parts of the application can gather, share information,
Yeah.
and make decisions as a group.
That's a great analogy. And this use case demonstrated the power of these systems to go beyond simple coordination
Right.
and facilitate complex interactions between distributed components.
Yeah. It's amazing how these systems, despite their humble beginnings, have found their way into so many critical and diverse applications.
They have.
But as they were used in more and more ways, did they hit any snags? Did they have to evolve to overcome new obstacles?
Of course. No system is perfect.
Right.
And both ZooKeeper and Chubby faced their share of hurdles as they matured.
Right.
One of the most common challenges they encountered was the need to scale to handle ever-increasing loads.
So it's like they built a sturdy house, but then suddenly everyone wanted to move in and they had to figure out how to expand the space.
That's a great analogy. As these systems became more popular and were used in larger and more demanding applications,
Right.
they had to find ways to handle more clients,
Right.
more data,
Yeah.
and more requests.
It sounds like a daunting task.
It's a daunting task.
How did they manage to scale without compromising their core principles of speed and reliability?
Well, it involved a combination of clever engineering and some compromises along the way. Okay. ZooKeeper, with its focus on speed, embraced techniques like sharding, where the data is split across multiple servers to distribute the load.
Ah, so it's like dividing a large pizza into smaller slices, making it easier for everyone to grab a piece.
Yeah, you got it. And this sharding approach allowed ZooKeeper to handle a much larger number of clients and requests without sacrificing its performance.
Impressive. Now, how did Chubby approach the scaling challenge with its emphasis on reliability?
Chubby's approach was a bit more conservative.
Okay.
It relied heavily on client-side caching to reduce the load on the master server.
So it's like storing a copy of the most frequently used items in a convenient location so you don't have to keep going back to the main storage.
Exactly.
Okay.
Clients would cache data locally,
Right.
reducing the number of requests they had to make to the master server.
Okay.
This helped Chubby maintain its reliability even as the number of clients and data grew.
It sounds like a balancing act, finding ways to distribute the load without sacrificing the core principles of the system.
Indeed. And both ZooKeeper and Chubby had to make trade-offs and adjustments to find the right balance for their respective use cases.
Makes sense. Now, besides scaling, were there any other challenges they had to overcome?
Oh, absolutely. One of the trickiest challenges they faced was dealing with the unpredictability of real-world networks.
The internet. The land of dropped packets, latency spikes, and unexpected outages.
Exactly.
Yeah.
These systems were designed with the assumption that networks would be relatively stable and reliable,
Right.
but in reality, networks can be flaky,
Right.
and that can cause all sorts of problems for distributed systems.
I can imagine. How do you design a system that relies on communication between servers when that communication can be so unreliable?
It's a tough problem,
Yeah.
and it required a lot of creative solutions.
Right.
Both ZooKeeper and Chubby had to implement mechanisms to handle network partitions, where servers are temporarily disconnected from each other.
So it's like those moments when your phone loses signal and you can't make calls or send messages.
Yes.
Except in this case, it's servers that are losing connection to each other.
Precisely. And these partitions can cause all sorts of chaos for distributed systems.
Right.
They can lead to data inconsistencies,
Yeah.
split-brain scenarios where different parts of the system think they're in charge,
Right.
and even data loss.
It sounds like a recipe for disaster.
It can be.
How did ZooKeeper and Chubby prevent those scenarios from happening?
Well, they had to implement sophisticated algorithms to detect partitions,
Okay.
elect new leaders
Hmm?
in the disconnected parts of the system,
Right.
and ensure that data is eventually reconciled once the connection is restored.
So it's like having a backup plan for when the communication lines go down, ensuring that the system can still function and that no data is permanently lost?
Exactly. And these mechanisms were essential for making these systems robust and reliable in the face of real-world network challenges.
It's amazing how engineers have to think ahead and anticipate all sorts of potential problems,
Yeah.
especially when dealing with the unpredictable nature of the internet.
Indeed. And the lessons learned from these challenges have helped shape the design of modern distributed systems,
Right.
making them more resilient and fault-tolerant.
It's like they've paved the way for a more stable and reliable internet,
They have.
even in the face of unexpected disruptions.
Absolutely.
It's incredible how these systems, born from relatively simple concepts, have had such a profound impact on the internet as we know it.
They really have. And as we move into a future with even more distributed systems,
Yeah,
the lessons we've learned from ZooKeeper and Chubby will continue to be invaluable.
absolutely.
We'll take a short break here, but when we return, we'll explore what the future holds for these systems and how they might evolve to address the challenges of tomorrow.
Welcome back to the deep dive. Before the break, we were discussing how ZooKeeper and Chubby have tackled some pretty big challenges.
Yeah.
And it got me thinking about the core concepts that make these systems so successful.
Yes, it's easy to get caught up in the details, but at their heart, both ZooKeeper and Chubby are built on some remarkably elegant ideas.
Exactly. Take
Yeah.
ZooKeeper, for example.
Okay?
We talked about those nodes and how they're organized like a mini file system, but the real brilliance is how it keeps that data consistent
Right.
across an entire network of servers.
Right. Each server maintains a copy of that data tree, and they use what's called an atomic broadcast protocol to ensure that any changes are applied in the same order across all the servers.
So it's like having a perfectly synchronized dance routine, everyone moving in sync no matter where they are.
Yeah.
No one steps out of line.
That's a great way to put it. And this synchronization, combined with ZooKeeper's use of watches and ephemeral nodes,
Right.
allows it to handle a massive amount of traffic with incredibly low latency.
Yep.
It's like having a live feed of the most critical information, constantly updated and available to anyone who needs it.
That's really impressive.
Yeah.
Now, Chubby, on the other hand, takes a different approach, prioritizing reliability above all else.
It does.
I'm still trying to wrap my head around this Paxos protocol that it uses.
Sure.
It sounds incredibly complex.
Paxos is definitely one of those concepts that can take some time to fully grasp.
Yeah.
But it's a brilliant solution to a fundamental challenge in distributed systems.
Yeah.
How do you get multiple servers to agree on a single version of the truth,
Right.
even if some of them crash or lose connection?
Right. We talked about it being like a board of directors carefully scrutinizing every decision before anything is finalized.
Exactly.
But how does that play out in a system with potentially hundreds or even thousands of servers?
It involves a lot of back and forth communication between servers.
Okay.
They propose changes, they vote on those changes,
Right.
and they exchange messages until a consensus is reached.
Right.
It's like a very intricate negotiation process.
Right. Yeah.
Designed to ensure that no matter what happens,
Right.
the data remains consistent and reliable.
So even if there's chaos happening in the network,
Yeah.
Paxos keeps everything running smoothly.
That's right.
That's incredible.
Hmm.
It's easy to forget that all of this is happening behind the scenes,
It is.
powering the applications and services we use every single day.
Absolutely. We often take these systems for granted,
Yeah.
but they are truly the unsung heroes of the internet.
Right.
Think about it. Every time you search for something on Google,
Yeah.
send an email, or even stream a video,
Right.
there's a good chance that a system like ZooKeeper or Chubby
Yeah.
is playing a role in making sure everything works seamlessly.
It's amazing to think about the scale and complexity of these systems
It is.
and the brilliant minds that have created and continue to maintain them.
It is. Yeah.
They truly deserve all the credit for keeping the digital world spinning.
Absolutely.
But as we wrap up our deep dive into ZooKeeper and Chubby,
Okay.
I'm left wondering about their future. What lies ahead for these systems? Are they destined to become relics of the past, or will they continue to evolve and adapt?
That's a great question. While the specific implementations of ZooKeeper and Chubby might eventually fade away,
Uh-huh.
I believe the fundamental concepts they embody will continue to shape the future of distributed systems.
Right.
The challenges of coordination, consistency, and reliability are timeless.
Yeah.
And the solutions these systems have pioneered will continue to inspire new approaches and innovations.
So it's like their DNA will live on,
Yeah,
even if their physical form changes.
exactly. As we move towards a world of even more interconnected and complex systems,
Right.
the lessons learned from ZooKeeper and Chubby will be more valuable than ever.
It's reassuring to know that their legacy will endure even as technology continues to advance at such a rapid pace.
Yeah.
But all this talk about the future makes me wonder what new challenges might arise that will push the boundaries of what these traditional systems can handle. What might the next generation of distributed systems look like?
That's a question worth pondering.
It is.
As we move towards a world with trillions of connected devices,
Yeah.
with data being generated and processed at an unprecedented scale, we might encounter challenges that require entirely new approaches to coordination and consistency.
Right.
We might need to rethink our fundamental assumptions about how distributed systems should work.
It's both exciting and a little daunting to think about the possibilities and the unknowns that lie ahead.
Absolutely.
But one thing's for sure, the world of distributed systems is constantly evolving and the journey is far from over.
Indeed. And I, for one, am excited to see what the future holds.
Well, that brings us to the end of our deep dive into the fascinating world of ZooKeeper and Chubby. We hope you've enjoyed this exploration as much as we have. And remember, this is just the beginning.
It is.
There's a whole universe of distributed systems out there waiting to be discovered.
So keep exploring, keep learning,
Yes.
and keep asking questions.
And who knows, maybe one day you'll be the one designing the next generation of these incredible systems.
That would be great.
Thank you for joining us on this adventure.